Okay, welcome back. We are talking about 6.2, which is all about introducing lines and line segments. So, since we're introducing them, we should probably formally start off with their definitions. So if I take a look at a line, lines are a set of connected points in a straight path that go on forever in opposite directions. We can see that a line is specifically a line when I have those arrows on either side. That indicates that they do in fact go on forever. They do not stop. They continue that trajectory denoted by that arrowhead to continue in those directions. Now, for line notation, a line can be named in one of two ways. Way number one is we can use any 2 points along the line. So, for example, this line here, we have points A and B. But that's not it. Any 2 points along the line, and on top of it, we have to draw a line. Now, realistically, if there was a third point here, let's say this point was C, I can choose any 2 points still. I don't have to choose A and B. Most often we use the ones closest to the arrowheads just as a way to try and be consistent with other people, but it is not necessary. I could, in theory, call this line AC or AB or CB or I feel like those are most of the lines there. But that's one way to denote them. Now you'll notice in the second line that I have drawn here, I don't have any points labeled along it, but there's a lowercase letter drawn next to it. I am also welcome to name a line using that lowercase letter. So I can name that line lowercase m. Now line segments are different from lines. If you've ever heard the word segment of something, segment just means a part of. So a line segment is like a part of a line. So in theory, instead of calling this unit 6, we can say it's a segment of grade 9 math because it's a part of grade 9 math. So segment doesn't talk exclusively about lines. It's just denoting a part of something greater. So a line segment is just a small piece of a line that has distinct endpoints. I can tell the difference between a line and a line segment because a line will go on forever with arrows, whereas a line segment has 2 points at the end, or it could be denoted like this, right? I don't have arrows, but I can see that it stops. It's just a chunk of a larger line. Now, notation is actually kind of similar to lines, except the notation for a line segment uses specifically the endpoints. So even if there was a point in the middle, E, I cannot name this entire thing CE because that only implies this section of it. So it's very important that when we're naming line segments, we use the endpoints. Now there's also 2 ways that we could denote this. So if I'm talking about line segment CD, I can write CD with a line segment on top. However, line segments are quite often one of the most common things that we reference in this way. So they've also accepted that having the 2 endpoints with nothing on top also is an acceptable way to represent a line segment. So both this, the endpoints with a line segment on top, or this, the 2 endpoints with no line segment on top, are both equally acceptable ways to name a line segment. Okay, one specific thing that I want to point out is in diagrams, we often use tick marks to indicate which line segments are congruent. So which means they're the same shape and the same size. Specifically in line segments, talking about the same length. Okay? If there's more than one set of congruent line segments, so I can see in this diagram below, segment CB and segment CD are congruent because they have the same amount of tick marks. In a similar way, I have segment AB and segment ED are also congruent. And I can tell because they have the same number of tick marks. If I had a third pair that was also congruent, but not congruent to what's already there, I can have a third amount of tick marks to indicate that. Now, as I go here and I chat about this, hey, what happened? Okay, as I go through this and I chat about it, let's write down what we've got. So I can say that line segment CB is congruent. Remember, congruent is what I use when I'm not talking about numbers. I'm talking about shapes or notation. So CB, that segment, is congruent to CD. If you're like, well, Miss T, I wrote it as segment BC is congruent to segment CD. Awesome. And if you swapped the order here as well, that's also totally fine. Not a big deal. In the same sense, for these purple guys, I can say segment AB is also congruent to segment DE. But I know that this segment and this segment are not congruent because they do not have the same number of tick marks. All right, that's our lines and our line segments. Now, when I talk about lines and line segments, there's particular types that are a little bit more interesting to me, a little bit special. And those are parallel and perpendicular lines. Now, parallel lines or line segments, you could have either be parallel. These are lines or line segments that never meet. If I drew those lines and continued with the arrows and drew them on forever and ever and ever, they would never touch. In fact, they would always remain the same distance apart. So if I had 2 points on my line and I measured that distance, and I found 2 other points and I measured that distance, well, that distance would always stay the same. They never get a little bit closer. They never get a little bit further. They're always equidistant or the same distance apart. Now, I know how to name lines. In this case, in the diagram above, I have an L, a lowercase l, for my first line, and a lowercase m for the second, because I don't have points on here, and that's totally okay. If I want to write a statement saying line L is parallel to line M, I use this double slash mark. Now, we don't do it straight up and down because that looks like the number 11. Or it looks like I wrote LL somehow. But I draw these double slash marks. These slash marks typically are taller than letters. But this reads as if I'm saying line L is parallel to line M. Okay. Now that's the notation I use to state that things are parallel. But I want to talk about the notation that you have on diagrams to show that lines are parallel. Because it's never enough for me to look and be like, they look pretty parallel. I'm going to make that assumption. I never assume. I know something's parallel only if it tells me. And what they use in diagrams to tell me that lines are parallel is they use extra arrow symbols. And those extra arrow symbols actually go in the middle, or not on the endpoints, but somewhere on the line. And I use the same little arrow symbol on both lines to show that they are parallel to each other. Just like tick marks, if I had more than one pair of lines that were parallel, I'd have to make sure my notation's a little bit different. So here, I know that these 2 lines are parallel because they have that extra arrowhead in the middle of the line indicating so. But in this shape here, I have 2 other lines that also happen to be parallel. So instead of using a single set of arrowheads, I use a double set of arrowheads in the middle of my line to show that those 2 are also parallel. This helps me indicate that this and this are not parallel to each other because they don't have the same amount of extra arrowheads there. Okay. It's important that we do not assume things are parallel unless we are explicitly indicating that they are. So if they do not have those extra little arrowheads on them, we can't say yes for sure. So we would not indicate that they are parallel. Okay, perpendicular. Perpendicular lines, or again, line segments can be perpendicular too, that's great, are lines or line segments that intersect, they cross at exactly 90 degrees. So they form a right angle. Now I can see that in this case I have line L, and it's actually a line because they have arrows going on forever. And I have line M, and again for the same reason, arrows going on forever. These two things are perpendicular because I can see that where they meet, they form a 90-degree angle. Now, if I want to show that these two lines are perpendicular, and I'm showing that notation, I want to write it in like a little mathy sentence. I go line L and line M. The symbol is an upside down capital T because it kind of makes that 90-degree angle, right? If I'm looking at an upside down T, that angle is a 90-degree angle. That symbol indicates that I have perpendicular lines and or line segments. So this reads as line L is perpendicular to line M. In a diagram, I know that lines and or line segments are perpendicular if I can find that little square that represents a 90-degree angle. Just like I was talking about with parallel lines, if I don't see that notation there, I cannot assume things are perpendicular. Even if it looks close, I can't make that assumption. Well, let's jump into some examples. So when I take a look at this, I have a couple examples right here. What I want to do is a few things. Thing number one is I want to use proper notation to indicate any lines or line segments that are parallel to each other. Then I want to do the same thing for lines and line segments that are perpendicular to each other. And last but not least, I want to see if there's any line segments that are congruent. So I'm always looking for those symbols. If there's no symbols, I cannot make that assumption. So I'm going to look at this first example. I'm looking for parallel lines. See if you can spot some parallel lines. I'm spotting these two lines here. And I could tell because they have the same extra amount of arrowheads in the middle of the line. And to denote that, I have to label these things by their points because I don't have any lowercase letter on the outside. So I have line EF, and it's parallel to line GH. And that's the yellow stuff I've just highlighted. Now, do I have any other parallel lines? I sure do. Because I'm looking at this and I go, hey, there's two lines that have this triple arrowhead on them. So I can go ahead and make a statement about that as well. So I have line EG this time that is parallel to line FH. Now to take a look at that, those are all my arrowhead symbols. I don't have any additional arrowhead symbols. Now let's talk about perpendicular. Perpendicular, I'm looking for that square symbol, and I see that square symbol here. And I can see that square symbol meets up with this line EG and this line GH. So I can say those two lines are perpendicular by using the notation line EG is perpendicular to line GH. Now that's the only little square symbol that I have in my diagram, so I'm not going to be doing any more perpendicular lines. The last thing I'm looking for are congruent line segments. I don't ever talk about congruent lines because all lines go on forever, so they all have the same shape and size. But line segments I care about. And so here I'm noticing there's tick marks in between an FH and in between EG, which means that those tick marks indicate that those line segments are congruent to each other. Same shape, same size. So these are line segments. So I'm not drawing a line with arrowheads on top, but just a line segment on top. And remember the symbol for congruent is an equal sign with a squiggle. And that line segment EG is congruent to line segment FH. All right, and this is all I can say. There's no additional information about other line segments or anything else. So this is what I've got. Notice I've only written down statements that have appropriate notation to back it up. I did not say, oh, these kind of look congruent over here. Like I might say, oh, these kind of look congruent. I can't claim that. There are no symbols that indicate it. I can't make that assumption. So this is it. This is all. Can you pause the video and try the next one? Welcome back. Okay, so as I go through here, I'm going to start with parallel lines again. I see these extra arrowheads in the middle, and those lines actually have lowercase letters as options of ways that I can name them. So you might have said line C is parallel to line D. You also might have labeled it a different way and said line TS is parallel to line RQ. Because they're labeled in both ways, you've got options. So there's no worries there. But both of these are accurate. That's actually my only set of parallel lines because that's all I've got for those extra set of arrowheads. In terms of perpendicular, I see this little square symbol here, and the square symbol is along one line, which is line E, and along this line segment. So here I'm mixing and matching for my perpendicular, but that's okay. I have line E, and I can only label it as line E with the lowercase because I don't have 2 points along that line to make the other naming possible. And I know it's perpendicular now to line segment QP or PQ, also okay. And that's all I've got for those little small squares. So that's all I've got for perpendicular. Last but not least, I'm looking for congruent. And I can see that this line segment and this line segment are congruent because they both have the same little tick on them. So I'm going to say line segment RS is congruent to line segment QP. And for this diagram, that's all I'm able to say about it. There's no extra arrowheads in the middle. There's no extra small squares for perpendicular. There's no extra tick marks for congruent line segments. So this is what we've got. Okay, we've got one more example to seal things off. I actually would like you to pause it and try it on your own, and then we'll get through it together. Before we do that, on your diagram, there should be a third point here that I don't currently have labeled on my diagram. And that's point I. Okay, give it a shot. All right, welcome back. So I'm starting with parallel lines, and I can see there's this extra arrowhead there. So this line and this extra arrowhead here is parallel to this line. I've got options on how to name it. I could say line W is parallel to line X, or vice versa. X is parallel to line W. I can also name it CD with the line on top is parallel to line HG. Both okay ways to name this. If you chose a different 2 points along the line, also acceptable, but this is what I've got. Okay, next I have perpendicular lines. I'm looking for that small square. Now that small square attaches this line here with this line here. It is one of 2 small squares. So I'm going to have 2 sets of parallel lines, but it just says a pair. So I'm only going to deal with this bottom one here. Okay, so I have line little x is perpendicular to line little y. If you had chosen the top 2, that would also be more than okay. Right, so if I chose the top 2 as my perpendicular line, this guy and this guy, I could have also had the answer of line y is perpendicular to line w. Okay, next, I'm indicating a right angle. A right angle, just like perpendicular lines, will have that small square there. Both of these are right angles. And I'm going to label them using the 3-angle method because otherwise it would be too ambiguous, too vague. So I have angle FEG as the right angle. Or you might have also had angle IBD. And again, the order doesn't matter as long as the vertex is in the middle. A pair of congruent angles. So remember, angles are congruent if I can see those matching curve marks on those angles. And I see 2 angles that have those matching curve marks. So I'm going to name them again with the 3-letter naming. So I have C heading up to B, going to H. So angle CBH. And my second angle here, going from B to H to E. So as congruent to angle B to H to E. Okay, we are plowing along so well here. I'm going to erase some of the highlighting I have so I can start fresh. Next, I'm looking for complementary angles. Remember, complementary angles add to 90 degrees. So I'm looking for that small square, but I'm looking for that small square where that angle split up into 2. So here I'm looking, I see IBA and ABD together create that 90 degree. Together form that square. And there's no special notation for complementary, so I'm just going to say angle IBA and angle ABD would be complementary. Okay. Next, I have supplementary. Supplementary angles are angles that together form a straight line. My pro tip for finding supplementary angles, there are so many here, is to find one straight line. I'm going to choose this straight line here. And find something, a line segment, a line that juts out of it. So I've got this one. Those 2 segments of my whole big straight line are my 2 supplementary angles. So I have angle HEF and angle GEF being both supplementary. Okay, last one. Vertically opposite. Remember, vertically opposite angles exist when 2 lines intersect. So I'm going to find 2 lines. I'm going to choose this one. Why? I don't know. I just chose it randomly. And this one. Those 2 lines at a vertex. Vertically opposite angles pair angles that are opposite where that vertex is located. So I'm going to choose these 2 here. You could have had other answers, and that's more than okay. I'm going to label those 2 angles. So here I have IBA, and H, angle HBE. Whew. All right, good work. So that is it. That is all. There's some practice that follows. Please work on using that proper notation and getting it down as best as possible. And I will see you next time. Have a great day.